can we go over the Laplace?
From your notes that you sent?
Yep.
Or from the or from the past exam? I've got them all open. Okay.
Can we go through the first one that we did on Tuesday?
The one you did, okay? In your notes.
Yep, week 5.
Okay. Your notes. You made it as a PDF, didn't you?
Yep.
Your notes.
Yep. Quite easy.
Yeah. So I'm sharing the one you sent me. Is that right?
Yep. I'm not seeing anything yet, but
All right, I've got it now. So now I'm going to go to the screen and share it.
Yep.
I'm slowly getting there.
Oh, yeah. Wonderful, Lance. I can see it.
Okay. Right. You keep asking, you're all right with that? That's just the definition.
Yep.
Okay. You have to do most of the talking.
If you just go down.
Okay.
Yep. Keep going down.
Okay.
Further down. Yep. A lot. Yep. More. Further. Yep.
So you okay with this?
Yep.
Yeah. This is changing to a Laplace. Yeah.
It's just using formula sheets.
Yes. Good man. Yes.
The thing that I don't get is the when you have like derivatives. If you keep going down.
Right. Okay. You okay with this? Yeah.
Yep. I got an understanding of that.
The zeros is when the top is 0.
Yep.
And the poles are when the bottoms are 0, because it forces the function to go to infinity. Yeah.
Yep. If you keep going down.
Partial fractions, you okay?
Yep. I got an understanding of that.
Right. So that's all. So once you got once you've got the differential equations, you just substitute in this one.
Yeah. I don't get this one. Like, it just doesn't work in my head.
Can we go to another one with both? I'll annotate so you can see where so we can both have this.
Yep.
And a dy dt, but also y.
Yep.
Or shall we do this quickly?
Yes, please.
Okay. All right. I'll just wrap that off. What I'll do is I'll write down the formula down here, and then we'll go to a board. What am I talking about? Oh no, we'll write on the sheet because we can still see you working there, eh?
Yep.
Better if we keep on this sheet. We don't want need to go to whiteboard. Okay. All right. Okay. These two things here are just formulas, aren't they?
Yep.
And if you happen to have a look at those videos of cards, it explains it beautifully. Now, where they come from, the derivation of it, where you derive it from. So I'm going to change the color. That's a horrible color, that yellow. What do you think a good color is?
Green, I guess.
Green stands out. Okay, that's us. Right, now, are you okay with that formula? Those formulas are, if you get a function of t, that's to get the Laplace transform. So anything with t is a function, and you put a Laplace on it, you get the variable s.
Okay.
you get S's in terms of S's, but you've done enough to know this language. Okay.
Yep.
That's just straight from the formula sheet. So let's go now to the differential equation. Okay, the differential equation says dy squared. I'm going to write down here.
Yep.
All right, I'm going to write down here. I'm going to write all over here, and you can tell. F double dash. This is our differential equation, right?
Yep.
Now the first one is a double derivative, right? The first term of the differential equation is there.
Double derivative.
Because it's double d2, it's the same as f double dash.
All right.
Yeah. So we're going to find the Laplace of the double. The Laplace of the double from the formula sheet. Yeah.
Yep.
Okay, so I'm going to write it out, and you check my algebra. So the fourth derivative over here, x Laplace is s squared. I'm going to write it down here. Oh, green doesn't look very good there on the white. I'll go red.
Okay.
So s squared. Oh, that's better. F of s minus f times f of o minus f dash of 0. That's straight from this thing here.
Yep.
Yeah, straight from there. Minus, what I'm doing is I'm putting it in the differential equation. I'm finding the Laplace transform of the differential equation 4 times, and the Laplace of the first derivative is just from what you circled, and the formula sheet is okay. You better check what I'm doing in case I get it wrong. Does that make sense? All I'm doing is replacing the derivative of this thing. The Laplace of the first derivative is this. Yeah?
Yep.
The Laplace of the second derivative is. And what I'm doing is, this is the Laplace transform of the differential equation. That makes sense?
Yep. I'm just processing that.
What I'm doing, I haven't gone up to your stage here. That's the step before this step on your notes. So what I've just written in red should go here before this step. Yeah?
Okay.
All right, I'm going to rub that off because it's getting messier there. So before you've got your step here, this is what they should go down. Yeah?
Okay.
And where did I get that from? You explain. Where did we get this from, what we got now in red?
Is it from the bottom function?
All right. From differential equation, from this differential equation here, yeah?
Yep.
We substituted in the Laplace of the double derivative. F double dash on the bottom is the first term, e squared y. Yeah? All these things here is the Laplace of a second derivative, this thing.
Okay.
Okay, so the Laplace of that double derivative is what I've got here. I'm underlining it now. Yep.
Okay.
That's just the Laplace of this thing here. I'll put a big arrow, yeah?
Okay.
And now I'm putting in the rest of the differential equation. Minus 4 times. Now I put in the this, the Laplace of any derivative, the first derivative, this thing here, is the Laplace of the first derivative, is this thing here. So I'm putting it right here. So all I'm doing is replacing the second derivative and the first derivative by their Laplaces. Yeah?
Oh, okay.
Yeah? There's nothing new. All I'm doing is substituting. I'm rub this all off. So that's what you're going to do in the test, in the exam. It's just substituting things straight from the formula sheet.
Yep.
Now from now on, it's just algebra. So you agree with that step? Can you check what I've got in red?
Okay, so you know your first function.
Yeah. Can you see where the arrows are going?
Oh, yep.
And all I've done is substitute the, because this is the Laplace of any, you see, this is just f dash. And this here is just f double dash, isn't it? And the Laplace of the first dash, I mean this, I'm putting it down here. And the Laplace of a double derivative is s squared and all that. The first thing that I underline. So all I've done is substitute this from your differential equation. You start with the differential equation.
Yep.
Second step, substitute in the S's, which is transform the classes. So now I've got that. So you're ready to move ahead?
Yep.
You ready to move forward?
Yeah, I think, yeah, I get it. Like the first, you know, when you start out with this problem, you've got one derivative that's,
equation.
Yep, a differential equation that's been derived twice, one that's derived once, and then
Yes.
the formula will say the first
So
derived.
the of those, you put it in form of S, yes.
Yep.
All you're doing is substituting again differential equation. Good, good. And you can explain it to your mates, your classmates, and it will consolidate in your own mind. You know, as you teach them, you will remember. Okay, let's do this together.
Yep.
So I need a bracket around here. Yeah. All right, ready? S squared Fs. Yeah.
Yep.
Have you got one of those fancy stylus pens?
No, all I've got is a mouse.
Oh, okay, it's hard to draw with the mouse. I'm using my finger at the moment. Okay, ready?
Yep.
So all I'm doing is substitute things in from these conditions. I'm going to circle the conditions. Are you watching?
Yep.
This thing says this when t is 0, y is 0. When t is 0, y dash is 6. Yeah?
Yep.
Okay, so let's look for those in here. So in here, the second term, we've got s squared f of s minus s times f of 0. Now that is 0, isn't it? Because s times 0. Because of these conditions at the top. It says y. Y is just f. Y is just f for some reason. Yeah?
Okay. Yep.
So y0 is just f of 0. So that's 0. I'll put in the first.
Sorry, Lance, I can't hear you, Lance.
Okay.
Oh, no, I can hear you. Yep.
Okay. As soon as I go to the side a little bit. Okay, can you still hear me?
Yep. Yeah, when you go to the side, the mic doesn't.
Yeah. But I have to go to the side because if my finger blocks my view.
Oh, right.
I can't see the screen. Okay, I'll try and look over the top of. Okay, ready?
Yep.
Now, if you look at this f dash of 0, it's 6, isn't it? F dash, remember f is just y.
Yep.
It's letters everywhere. So minus 6, yeah?
Yep.
F dash of 0, or the value of the derivative when x is 0, t is 0. Okay, now the algebra again. 4 minus, you tell me, 4s, yeah?
4s.
S
Oh,
all
yeah,
around.
s only
You
equals
bring the
s
other bracket.
equals f 0.
All right. 4 times f0. And if you go to the top, f0 again is 0, yeah?
Yep.
This thing here is 0. So f0 is just y0. So minus 0. So minus 4 times 0. I'm just doing the algebra thing, yeah? 4 times is if.
Oh, yep.
Let's tidy that up. Now I've got, this is 0. So I've got s squared. So I'm going to go back to your step. So look at your writing.
Yep.
SF squared, yep. That's where that came from. S times 0, gone, yep. Because it's the same as this, my one. Minus 6, yes. We got the same, yeah. Are you there?
Yep. Yep. I got that. Yep.
I'm just going through your working step by step. Minus 4 times S times Fs, yeah. Same as, oh, that was a big thing. And this 0 is gone. So what have you got left? We got, now change to the page down the bottom. Remember the page down the bottom here?
Yep.
Okay, I'm gonna rub everything off. We're now down to S squared Fs minus 6, just like you've got. Ooh, I'm gonna rub some of this stuff off. Minus 6, yep. I'm going back to this step here, still on the other page. S, I agree, yep,
Yep.
yeah. Minus 6, because that's gone, yep,
6.
Minus 4 times S times Fs, yeah. And 4 times 0, of course, is 0, so that's it. Oops. Yep. So you're okay now with that step.
Yep.
All right. So we haven't done anything. Yeah. I think the transition from this step to this step was the one that got you, didn't it?
Well, yeah, I
From
think.
here, from this to here is what you didn't understand, but now, yep. Sorry. Yep. What were you saying?
Yeah, because when I looked at it, I think what I didn't understand was you know how you've got the first derivative, the f dash bracket t close bracket.
Yeah.
I didn't fully understand that, and then I didn't fully understand f double dash
Right.
bracket t bracket. But the reality is it's just if you just take what they equal and then
Right.
put it into that formula at the top with the
Right.
d squared
D
t.
squared. Yeah. So what we have to remember is, remember this thing here, the double derivative of anything. Well, I'll use dy dx.
Yep.
Is equivalent to what we're calling f double dash, isn't it?
Yeah.
That's all. And the first derivative, dy dx, is just another way of writing f dash, 1 dash. This is called a Leibniz notation by whoever did it in the old days. And the dash notation is called a Newtonian, which we know because of Newton. Yeah.
Yep.
That's all. So but that threw you, didn't you?
Yeah.
Because why every double dash, and what's that got to do with the differential equation? Fair enough, yeah. Now, differential equation usually use the d squared notation.
Yeah.
And Leibniz notation use the dash notation. That's why.
Yep.
Okay, so shall we go back to the other page now?
Yes, please.
Okay, ready. Whoops. I've gone down a bit too far. Oh, no, up.
just out of curiosity, Lance.
Where am I?
Oh,
Have I gone too far?
I think you have to go down.
I'm going down.
Oh, you're going up.
Am I?
Yep. Yep. You gotta keep going down.
Am I going the right way now? Yeah.
Yeah, I think so. Yep. Keep
Oh,
going.
there it
Oh yeah,
is.
there you go. Yep. Keep going down.
I'll keep going. Yep. Yep. Okay, I'll wrap this off. Keep going. What you were saying something and then I interrupted.
I was
You were
thinking,
saying
Lance,
something. Yeah.
like because you have a pretty good handle on like this level of math, say.
Yep.
Have you
Yep.
considered being like
I have to look at the stuff though because I haven't done it for years. That's why it was good that you sent this. Have I? I'm too old if you're telling me.
No, I was just thinking like because we can only have Wayne for like maybe an hour.
Yeah.
Like maybe the opportunity is to create like create you as a tutorial, like someone who does the tutorials for these.
Well, that's my job.
Yeah,
That's what
group
you
tutorial.
guys. That's my job is to support you guys. So you guys organize it, and I'm very impressed with the way you guys communicate to each other. But it doesn't look like the other. I mean, you're doing all the communicating, eh? Are they?
Uh,
What about?
I think they're learning. It's just
Yeah.
yeah, oh, you know, the students. Like I've been through the whole thing, so I know how important it is to communicate.
Yeah.
I think they just don't realize how invaluable your help is. So
Tell them.
I'll keep telling them.
So when they watch this video, are they gonna see all what we're talking about?
Yep,
Even the vocal, even the audio?
yep.
Oh, great.
I'll
So
send you
tell them.
I'll send you how to do it as well.
Yeah, and tell them. All right, ready?
Yep.
Now, the last step now. Oh, what happened? Are you looking at my camera? I mean, are you looking at the,
Yep, I'm looking at the notes. Maybe you just clicked out of screen.
oh,
It still says that you're sharing.
okay.
Yep.
I'm back on the screen now. Are you okay?
Yep.
You're looking at your notes. Okay. All right. So that's what we've got so far. So we've got everything. That's Laplace's equivalent of that differential equation. But everything in S. Now, I noticed that when you do your notes, you always write reminders. You say, Wayne likes doing this. That's great. So this one, when you get to this stage, I'm going to write it here and make a note. Make f is the subject. So we want the function is the subject. So write it in, just like you do on your notes. It's like a little note to yourself.
Yep.
And I hope your classmates can see all this conversation. It's very important. All right?
Yep.
So you s squared times something times something times something. That makes sense?
Yep.
Now, f of s appears twice, appears in the first term. The second term is minus 6. Yeah. The third term, yeah, if s is there. And that's it. So what I have to do, algebra-wise, is leave the stuff with fs on the left and take the rest on the other side. So I'm going to take 6 over, becomes a positive 6. Yeah.
Yep.
And I'm going to factorize out fs because I want to make it the subject. Fs bracket. I need a s squared, yeah?
Yep.
Minus 4s, yeah? That makes sense?
Yep.
Yeah. So now fs, now take the sf on the other side and you've got this, yeah? So all you've done is make fs the subject. Take that bracket to the other side.
Yep.
Can you still see my red writing?
Yep. I can see it.
Yeah. That's all we've done is chuck everything to the other side and leave fs. And once you get to that stage, oh, why do you say the above is wrong in your notes?
Um, I think. Oh, I think Wayne made a mistake.
Yeah.
But you know how like if you go, um, I think what it means is, yeah, Wayne made a mistake there. But he said he was gonna redo it. But he never really got around to it. But I think the steps are correct though. So if you go Fs equals 6 divided by s squared 4
Over 4.
over
Oh, minus 4s.
minus 4s.
Oh, here we go. Shall we start this one?
Yep.
Because once we get, so we keep going with that thingy now, quickly. The one we just done, I'll rub my stuff off. Just to finish it off.
Yep.
Because I can't see any mistake. So once you get to that stage, now you recognize this as one of the, oh, instead of talking, I'll just do it. Okay.
Oh, where's my... Oh, here you go. Yeah, because now it's in the form of
Yeah, it's all it's that's the it's now in the Laplace's form with s's in it.
Yep.
We started with t, and now we're in s, so we converted it into a Laplace transform. So now we're gonna go back, express that as partial fractions. Does it ring a bell now? The word partial fractions.
Yep.
Now we do the partial fractions and then do the inverse, and bingo, we got the solution for the differential equation. Okay. Instead of talking, I'll do it because I'm aware of what the other guys would be listening to when they watch this. Okay, ready?
Yes.
I'm going to write with my finger here. So 6 over s squared. Let's factorize out the s because we need some factors, linear factors. S minus 4, yeah, that's better. Yeah, this thing here, fs.
Yep.
Now you can see that. You can see by on the right hand side, it looks like it's going to be partial fraction. Yeah.
Yep.
So I'm going to go and write on this side. Got lots of room here. A over s. Remember that. I'm going to find a and b so that we've got two factors. Partial fractions now. Yeah.
Okay.
I want 6 over s minus 4 to be equal. We want to find some value, some constants a and b, so that that statement is true. Remember the partial fractions?
Yeah, I remember a little bit from up there, but yeah, I'm relearning it as I'm just getting refreshed.
Oh, good. Okay, so now it is saying if we rearrange this, A will go with the thing that's under B, yeah?
Yep.
But we won't worry about that algebra because you've done enough of it. We'll just go straight to it. A times s over 4. If we expand it out using the algebra, and B will go with the thing that's under A, S must be equal to 6, the top. Yeah?
Yep.
That's a technique. Yeah? Because the bottom will be the same. Am I being too fast?
No, I get where you're going.
Yeah.
Yep.
All right. Okay. And the way you guys do it, it's very good. It's fast. So you look at these two factors here. You say when s is 0, then this the b term will disappear. Yeah.
Yep.
I see that your notes, and you said when s is 4, that makes this one 0. So the a term will disappear. Yeah.
Yep.
Okay, so let's write it down. So in the exam, I would still write it down. Okay, s is 4. When s is 4, I'll still write it like this. Then this side is still 6 equals a. This will disappear. Yeah, A will disappear.
Yep.
And the only thing is 5B now, yeah?
Yep.
Or S, sorry. S is 4, sorry, isn't it?
Yep.
So it's 4 times B. 4, because this is 4 times B. So B is, take the 4 to the other side.
6
3 over
divided by
2.
4.
6 divided by 4. 6 over 2, yeah?
Yep.
All right, so now when S is 0, for this term here, that term will disappear. Then the left-hand side will still be 6. The right-hand side will be A 0 minus 4, yeah?
Yep.
So minus 4A, whoops, equals 6. So A is equal to minus 3 over 2. All right? But all that, see, you get lots of marks just by doing that partial. You see, it's 10 marks in the exam. So just by substituting things, get things in S, and then doing your partial fractions, you already got full marks. All right. So
Yep.
let's now, I'm going to rub everything off, and we'll remember what our A and B are. Okay. I'll rub everything off because it's too many. Okay. But this is captured in the video already, isn't it?
Yep.
Oh, great. Okay. So our A is 3 minus. Right. Oh, I have to go back to draw. A is minus 3 over 2, and B was 3 over 2. Yeah.
Yep.
Now your F is now, I'm going to rewrite this thing here, is now minus 3 over 8, 3 over 2. I write it like this. I just put A by itself on the top. Over, remember the A over the partial fraction over S. Remember?
Yep.
Plus B over S minus 4. We are expressing this fraction as partial fractions, as this. Yeah? Yeah?
Okay. Yep.
Now 3 over 2 is A over S. And B is positive 3 over 2. I just write it like just as it is. B on the top over S minus 4. All right. So how easy is that? Now you've got, remember our Laplace is inverse Laplace. Let's go to the table. Our inverse Laplace. I've got my one written out.
Oh, yep.
So what's the first term? The inverse Laplace now. So the function, the t function now is inverse of Laplace. Is now the answer to the differential equation.
Yep. So the first one would be minus 3 above 2 plus 3 above 2.
That's it, eh?
And
It's
then,
just a number, isn't it?
yeah.
I can't find my table yet. My list, formulas. Oh, yeah, found it. So change that and see what you come up with. I still haven't found it.
That effectively becomes 0 because negative plus positive
formula sheet.
Yep.
Oh, here's my table. Well, I've got the first one looks like A over S, isn't it? From the formula sheet, it looks like something like this, isn't it?
Yep.
And the second one looks like 1 over S minus A. See the formula sheet?
Oh yeah, sorry, I didn't see the second one. Yep.
Yeah. S minus 4. So my inverse Laplace will be minus 3 over 2.
Yep.
Yeah. It's just a number in the top.
Plus.
And the Laplace for the other one is plus
E to the power of.
E to the power of 1 or 4.
Yep. E to the power of 4.
4t, but with a number in the front.
Multiplied.
The one I put on the
Yep.
top, we stick it in the front.
Oh, yep. Yep.
It's 3 marks.
Nice. Yeah, I got that.
All right.
Because I think I didn't see the S, because you know there's that squiggle minus 4. Should be S minus 4.
I'll clean that up because it's on the video. This one here.
Yep. Because it's S minus 4.
I'll do it now because the other guys will be watching it. You're right. There. Yeah?
Yep.
Okay. So that's all the steps. Let's go back to the steps, shall we?
Yep.
And we write it out as we go. The first one was look at the table, the formula sheet, and replace the double dash, change the Laplaces. Which means look at the differential equation. Well, let's use the next example as a.
Yep. Yes, please.
This one. First step, use the look. Can you see in my red writing?
Yep.
Read that. Substitute it using the Laplace transform equivalent of the double derivative and the one single derivative. Yeah?
Yep.
That's the first step. And then the next step, once you get that, are you writing this down?
Oh,
Oh, you know the steps anyway, by the way.
but as we go through it.
Step, yeah.
Yep.
Oh, what did I do? I highlighted it. Oh, yeah, there we go.
Yep. So I mean, the first step is the F double dash, which means you have to use that S squared Fs minus S4 minus 9. So you're using that formula.
Yeah, you're using the formula sheet. That's all you do in the first step.
Yep.
Go to the differential equation.
Because the first half up till the 5.
This is the differential equation, yeah.
Yep.
You want to solve.
Yep.
In other words, find the function y. In function y, when you do the, it's that when you do it, when you convert it to the Laplace transform, the y is actually FFS, which is what you see over here.
Yep.
Yeah. Well, once you change everything to Laplace transform using the formula sheet, you've got this step. Yeah?
Yep.
The first step. And what was the one that we did? Make Fs the subject.
Yep.
Yeah?
Yep.
Chuck everything to the other side and make the function f of s the subject. That's what we did.
Yep.
Shall we follow the example on this one?
Yes, please.
That's done. All done. let's check. 2 times that is 2s squared. Yeah, I got it. Agree with me?
Yep. Fs.
Yeah. 2 times, I'm removing the bracket, minus s times 4 is minus 8s. Yeah.
Yep.
And
Minus
then
19.
9 times 2 is
8,
18.
oh,
Yeah.
yeah, 18. Yep.
Okay,
Plus
so now we're removing this bracket, the big bracket, this one. F times that is
5.
5s Fs. Yeah.
Yep.
Agreed. 5 times 4 is
20.
20. And then, of course, this one is still there. Okay, so I rub everything off, and then we'll carry on. So we agree. So now, just tidying up. I'm moving it down. Can you see that?
Yep.
Oh, these conditions were very important, weren't they? This one. These conditions here,
Yep.
because that's where these things came from, and that 4, and that 4, and so on. Yeah.
Yep.
All right. So now we've got 38s. Where does 38s come from?
If you just get
1s. How did we get this?
minus 8, minus 18, minus 20.
Oh, okay, I got it. When you get this, when you take these two to the other side, get minus 38, and then it becomes 38 when you go to the other side.
Oh, okay. And then where did you get the 8?
Where did you get the 8?
Oh, yeah, there's an 8 over here. Oh, no. That's 8s.
8s. So put in the s. I'll put in the s, but you put in your notes as well. 8s, yeah?
Yep.
Yeah. So add it into your notes now, because this is a copy of your notes.
Oh, it's all right. What I'm going to do is I'm just going to understand all of this through the video. And then, because what happens is I take too many notes and then I don't understand the process. But since it's a video, I'll just it's just a matter of going taking speeding up the video and be like, yup, nope, 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 nope.
Right, so we got that. Okay. And when we factorize, now we're in the easy. The rest is easy now because we're used to partial fractions now.
Yep.
Once it's in this form, this is easy now from now on. Yeah?
Yep, because it's just partial fractions.
Yeah, and then once you get to this step, now this is sometimes because I'll wrap some of this stuff off. Because in every final exam I've been watching, you start off with just having Laplace transform and then find the inverse, yeah? And 1 mark, 1 mark, 1 mark. You probably saw that, eh?
Yep.
In the notes. Okay, so you get something like this. So we get 12 over. I'm going to write it because it didn't look, the way it's written here is quite convenient, but it didn't look like that once I'm going to rewrite it. Once you've got these two things here, like, are you watching?
Yep. I'm watching the screen.
Okay, B is minus 2.
Yep.
And you got A was what, 12?
Yep.
Yeah, just from, putting in S equals minus 3, that's great. S equals a half, because that gives you that the B term is 0. Okay. Now, when you first put in the values now, A is 12 over 2S minus 1. It's not, doesn't look very easy. But you guys went straight to that thought, which is great. But how, when you look at this and try and do the inverse, it doesn't look very friendly.
No.
You know what I mean? So, it's a 2S. Oh, I used to just seeing the S, you see. That's why you brought the 2 out here. To make it look right.
Yeah. I think you missed. It's 2s minus half.
Yes. But we are used to seeing S and then something, another constant. S. But when you see the 2S, you start worrying. Like, oh. But the trick that you guys did was good. So you bring out the S or the 2 outside. I'm going to go here. You bring out the 2 outside, and so you got now S is now by itself. That looks familiar now. And on the top, you still got 12. So now I can, and I'm used to seeing 1 on the top. So I'm going to take out these 2 outside the bracket. So now I've got 1 over. Now that looks like something on the formula sheet, doesn't it?
Yep.
Right. So now this is just 6 now. And then that one is straight up. What was it? Give me the e to the power of?
E to the power of, yep, 0.5 t.
Bingo.
And then you go 12.
And the 6 over 2 is the 6. So if you see something like that, write it out first like that, and then say, oh, I want to do some tweaking to make it look like the formula sheet before you, because it's very easy to lose marks when you've done all the hard work the last stage.
Sweet.
All right. I think you've done it.
Cheers. Thanks, Lance.
All right. Do you want to do something different? Or you'll stick with, I did follow the past exams, and I was quite pleased with it. All right. So tell the rest of the gang.
Yep. Yeah. They don't use you enough, and yeah. I'll get them to talk more.
Yeah.
When I send this video out, I'll send you a link as well, so that way yeah, and then yeah, I'll just keep.
Tell me what to do.
Yeah, we'll ask you what to do, and I'll see if like what we can do is like after every lecture or every tutorial, I'll send you my notes, and then like I'll make it like you know, if you want to ask Lance, like see when you're available, and maybe that can be like a continuing tutorial time with you.
Yeah.
Sweet.
All right. Okay.
Have a good weekend, Lance.
Is there any quick question you want to ask about before I go?
Nothing yet.
Just all the Laplace today.
Yeah, I just gotta. I'm really far behind in terms of study, so I couldn't ask you more than this at the moment.
Okay. All right. So make sure you tell me beforehand.
Yep.
What you want to talk about, so I'm ready.
Oh, easy.
Yeah, because I did a lot of homework, and I'm pleased I did.
Yep.
Okay, we'll catch up later.
Sweet. Thanks, Lance.
Okay. Right, where do I go?
I think you just go leave, end meeting.
There it is. Okay.